Hello friend, welcome back to my video. In this video, I will discuss question paper 2025 physics paper. So in this video, you can read this instruction. Question 1 and 5 are compulsory. We know that. So come to the point. So first question is, consider a large stationary cylinder of a inner radius r, a smaller solid cylinder of radius r roll without slipping inside a large cylinder. Determine the equation of motion of a smaller cylinder. Question B. Derive for expression gravitational self-energy of a uniform solid sphere of mass m and radius r. And question number C. A particle of rest mass 1 kg and velocity of magnitude 0.9 c coulomb collide with a particle of mass 2 kg at rest. After the collision of two particles collapse for the single particle of mass m and velocity v. Determine the m and v. In question number D here, in a double slit Fraunhofer diffraction experiment, the slit width is 0.12 micrometers and the spacing between the two slits is 0.48 millimeter. The distance of the screen from the slit is 1.5 meter. If the wavelength of the light is used is 600 nanometer, determine first the missing order of the interference maximum, and question 2, distance between the center maxima and the first minima. And question number E is here, a light beam of wavelength 600 nanometer produced by 20 megawatt laser source is incident on a plane mirror. Determine first number of photons per second striking the surface of the mirrors. Option B, force exerted by the light beam on the mirror. So question number 2, a body move about a point O under a no force, the principal moment of inertia at O being 3a, 5a and 6a. The component of the inertial angular velocity about the principal axis are omega 1 is equal to n and omega 2 is equal to 0 and omega 3 is equal to n. Find the component omega 1, omega 2 and omega 3 for a large value of a time t. Question number B. A harmonic oscillator is represented by the equation m d square x by dt square plus gamma dx plus kx. This is the equations. So where m is equal to 0.25 kg, gamma is equal to 0.07 kg seconds and k is equal to 85 Newton meter. Determine first period oscillations, second number of oscillation in which amplitude will become half of its original value. Question number C. So the electromagnetic wave equation is invariant under Lorentz transformation. Question number C. Consider a laser consisting of an active medium placed between a pair of mirrors forming a resonator. Obtain an expression for threshold population inversion required for the oscillation of lasers. And question number B. For a helium neon laser system, what will be the magnitude of delta omega d, which represent FWHM of a line shape function, if resonant frequency 3 into 10 to the power 15 second and temperature T is equal to 300 kelvins. Question number C. A cube of mass m and side A is rotating with angular velocity omega around one of it is which is say along the x-axis Obtain the expression for its angular momentum and kinetic energy. So given that, you can see this. Question number 4. Consider a thick lens T made of a material of relativity refractive index n. Let R1 and R2 be a radii of curvature of its two surfaces. Obtain the systematic of the lens. Question number B. Consider a multiple reflection from a plane parallel film of thickness h and refractive index n2 derive an expression for the total reflectivity from the surface to the film. Question number C. A solid shaft of mass m, length l and radius r is to be replaced by a light hollow shaft of the same length l and having the same rating of torque upon theta, where torque is the couples and the theta is angle of twist. Estimate the percentage reduction in a mass of a whole shaft is outer radius of the shaft is twist the inner radius. Assume the material of a new shaft is same, that is replaced shaft. Question number 5, section B. Consider a point charge of 5 Newton Coulomb placed at a distance of 1 meter from a perfect conducting plane z equals to 0 of infinite extent. Find the electric field at a point 220 meter, and so it is normal to the plane. Question number B. A rectangle coil consists of 15 closely wrapped turns and has dimension of 0.5 meter into 0.4 meter. It carry a current of 0.5 A. If a uniform magnetic field B 0.T is applied such that the direction of magnetic field make an angle of theta with respect to the planes of the coil. What is the torque Q exerted on the coil of magnetic field? Question number C. State and explain Kirchhoff's current law and Kirchhoff's voltage law. Derive the law from the principle of charge conservation and energy conservation. Question number D. A parallel plane capacitor having circular plate of radius 10 cm is being charged. If the electricity field of an instant with the capacitor changes the rate of 5.0 volt meter per second, calculate the magnetic intensity H inside the capacitors. Question number E. A reversible heat engine operates with their receiver at 300 Kelvin and 400 Kelvin and 12,000 Kelvin. It absorbs 12 kilojoule energy at a heat from the receiver at 12 Kelvin and delivers 4 kilojoule work. Determine the heat interaction with other two receiver. So question number 6 here you see. Consider a long straight wire of length L carrying in a current I. Determine the magnetic vector potential A at a point P located at distance x from the wire. And question number B is here. Diagram look. You can see this. And as so in the figure, a series circuit connected across a 200 voltage 6 Hz line consists of a capacitor and reactance of the 3 ohm, a non-inductive resistor of 44 ohm, and the coil inductive reactance 19 ohms and the resistance 36 ohm. So you can see this diagrams and determine one by one power factor of the circuit, power absorbed by the circuit, power dissipated in the coil. And question number C. Consider a mixture of Na molecule of a monoatomic gas A and Nb molecule of a monoatomic gas B. From this mixture obtain the hole's free energy and pressure. The particle partition function for a monoatomic gas is 2 mkt upon h square 3/2. So this is previous year's question paper. I find that this is previous year's question paper, but in this year's ask numerical question in this question. So question number 7. In a ternary system consists of 3 components A, B, C in equilibrium with 2 phase. Determine the number of degree freedom using of give phase rule and discuss the effect of pressure and temperature variation on the phase equilibrium. Question number B. Discuss brief of consideration which led van der Waals of modify the gas equation. What are the critical constant of a gas? Calculate value of this constant in the term of constant of the van der Waals equation. Question number C. Consider a conducting sphere of radius A in a uniform electric field E. Find the induced surface charge density on the sphere and determine the electric field E at a point P characterized by a radius factor R. Question number 8. In a free space, an electric field E is given by the following expression: E 10 cos omega t minus 100 x j Vm. Find the angular frequency and the displacement current. Question number 8b means A2. An electromagnetic watt has a magnetic field B into 5 into 10 to the power 8 Tesla. Determine the magnitude of the pointing vector. Pointing vector. So question number B. Explain why at equilibrium the chemical potential of a component must be the same in a coexisting phase. Drive the equilibrium condition for a binary liquid vapor system in the term of chemical potential. And question number C. Drive Planck radiation law of black body radiation using the Bose-Einstein distribution function. Explain how the result of quantum statistics differ to classical result derived from the Rayleigh-Jeans law. So this is the last question and end. So this video has helpful for mains exams for you have select to UPSC optional for coming years for physics optional. So thank you for watching this video. Have a good day. Have a nice day. Best of luck for who are preparing this optional subject.